Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.5, Problem 6. This is Section 15.5, Problem 6. It says, find the area between the function f of x equals x squared, shown in red, and g of x equals 2x, shown in blue. So let's just make this a little bit more clear. The g of x equals 2x is the blue. I'll write that right in. And then the f of x equals x squared is in red. And we want to find the area between them. So we're looking for this area that I'm shading in like that. So to find an area trapped between two graphs, what you need to do is take the definite integral of basically the top graph minus the bottom one. And I'll put a dx on the end of that. So within the area where it's trapped, the top graph is the blue one, the g of x equals 2x. As you get to other parts of the graph, then the red one comes higher than the blue one. But where we want to work, the blue one is the top graph. So for top minus bottom, the top is the 2x. Minus the bottom graph is the x squared. So we have to solve this integral. Now, part of the problem is this is going to be a definite integral. What are our limits of integration? Well, the limits of integration come from the points where the two graphs intersect. And from the graph that's given, it's printed right into the homework, one point of intersection down here you can see is 0, 0. 0 for the x-coordinate, 0 for the y-coordinate. The other point where they intersect is 2, 4, over 2, up 4. And what's more important to us are the x-coordinates. It's the x-coordinates that are our limits of integration. The fact that the y-coordinate here is a 4 doesn't do anything for us. The other point of intersection with the 0, 0, if you swap them, you won't get into trouble. But the 2, 4, if you swap them, you'll get the wrong answer. So one limit of integration is the 2, and the other is the 0. The larger of those two values, the 2 is the upper limit of integration, and the smaller, the 0, is the lower limit of integration. So by finding the definite integral of 2x minus x squared dx between 2 and 0, we'll find the area trapped between those two graphs. So to find any definite integral, what we want to do is first, step 1 is going to be solve the integral. So the integral of 2x, think of the 2x as a 2x to the first, will be 2 over 2x to the 2. Then minus x squared, that'll have an integral of minus 1/3 x cubed. The 2 over 2x squared, I can make that 1x squared or just x squared to simplify a little bit. And the minus 1/3 x cubed, I'm not going to be able to simplify that very much. So that's the answer for step 1, solving the integral. I'll put a long vertical line to the right of that and put my limits of integration in the 2 and the 0. So the next step, step 2, will be to put the upper limit of integration in for x. So the x squared becomes 2 squared. Minus 1/3 x cubed will become minus 1/3 2 cubed. And I'll do the math. We will have a fraction. It won't be too bad. 2 squared is 4 minus 1/3 times 2 cubed is 8. 2 to the third, 2 times 2 is 4, times the third 2 is 8. So let me simplify that a little bit. Instead of 1/3 times 8, let's make that 4 minus 1/3 times 8 over 1. 8 can be written as 8 over 1. Now we can multiply. We have a regular fraction multiplication, top times top, bottom times bottom. And since we're going to be in thirds, instead of 4, let me write the 4 as a 12/3. That's still a 4, but now in this form it's going to give me a common denominator. And now my 1 over 3 times 8 over 1, top times top, 1 times 8 is 8. Bottom times bottom, 3 times 1 is 3. So now I have 12 over 3 minus 8 over 3. Common denominator is 3. 12 minus 8 on top is positive 4. So for step 2, I have a result of 4/3. Step 3, put the lower limit of integration in for your variable. That's going to be 0. So I can write it right underneath because it's very simple. X squared will become 0 squared when I put in the lower limit of integration. Minus 1/3 x cubed will be minus 1/3 0 cubed. The zeros especially easy. 0 minus 0 is 0. So for the final answer, step 4, I'm going to subtract the result from step 2, 4/3, minus the result from step 3, so minus 0. 4/3 minus 0 is easy enough to do. It's 4/3. So the area between the blue and the red graph here is an area of 4/3. 4/3 square units, whatever units this would be drawn in, square inches or square centimeters or whatever.